Good morning, mathematicians. Today we are going to work on adding polynomials. Now we did a little bit of work yesterday with our algebra tiles. You can use those, or I'm going to show you another method on how to just do them on paper. As I'm doing adding polynomials, I do have a list in my head of what I do, and if you need to stop and pause the video and write these down to help you get through adding polynomials, you can do that. Okay, the first step is we are going to find our like terms. We're going to organize them where all the pieces look the same. Now remember, that means they have to have the same variable and the same exponent. The second thing we will do is combine like terms. If they are the same side, we'll add them. If they are different signs, we'll subtract them. I'll do a little bit more work on this as I do the problems. And then finally, we do need to write our answers in standard form. Remember, that is greatest degree, or the greatest exponent, to the least. So I'm going to set this aside right here, and I'm going to do a few problems. Now, the cool thing that I like about math is all the fun colors I get to do. I get to use in the beginning. Now, some of you may want to do this. You don't have to. It just helps me to stay organized. So I'll show you. Eventually you'll get so good at this you don't have to have all the colors or do all the circling. But in the beginning, I want you to practice doing the circling so it helps you to become more observant. Okay, we are going to add our polynomials. Now notice that the polynomials are really just kind of sitting next to each other. Sometimes you'll see them with parentheses, sometimes you won't. It doesn't matter as long as there's no negative in between. We'll talk about that when we are subtracting polynomials next. Okay, so to start with this, I am going to kind of organize by my exponents. I notice that I have an x squared, this one has no variable, and I have an x to the 1. So I'm going to go and circle all of my x squareds. I have a negative 7x squared, and I have a negative 5x squared. So I'm going to bring those together. Now, you can choose to bring them together now, or you can do all of your circling first. So I'll try each method. Since I have a negative 7 and I have a negative 5, they are same signs, so I'm going to add. And if you need to, remember, let's go back to our integer rules. The negative 7 tells me to go left 7, and then the negative 5 tells me to go left another 5, so that gives us a negative 12x squared. Remember, we work with our coefficients, and we keep the variable and the exponent. We do that just for adding and subtracting. Okay, I'm done with those. Let's go ahead and find our next one. I notice that I have a 2x, a positive 2x. Notice that I circled a sign with the number and variable, with the term. And then here I have a positive 10x. I know it's positive because there's no sign in front. So let's go ahead and pull these two together. If I have a positive 2x and a positive 10x, they are same signs. I'm going to add. And notice that I'm going right for both of them. I go right 2, and then I go right 10. So now I have a positive 12x. Notice I bring the variable along. I also use its sign as my operation. Okay, done with the x's. Now I need to see if there's anything left, and I do have a positive 14 and a positive 7. And again, same signs, so I'm going to go right 14 and right 7. And I'm going to end up with my final term of a positive 21. And so now we are done. This is our solution. Now I purposely notice that I found like terms first, then I combined them. As I was doing that, I was actually writing in standard form as well, because I chose all my x squareds, then I did my x to the first, and then I did my constants. My constants are always last. Now, number 2 and number 3 are very like number 1, so I am going to skip those so that you can come back and do them. But I'm going to move on to number 4. Number 4 looks a little bit different. It's a little bit more complicated. So again, I notice I have a polynomial here. And let's look at how many terms we have. We have 1, 2, 3, 4, 5 terms in this polynomial. And in this polynomial, we only have 1, 2, 3. So I noticed that some of them are not going to match up, and that's okay. Now, the first thing I want to do is find my like terms, and I am thinking about standard form. So I'm looking for my highest exponent. Well, I got a 5, 4, 2, 6. 6 is my largest exponent. So I'm going to go ahead and circle that one. Positive 6, c to the 6th. Now I'm going to look for my 5s. Now remember, I said there's two ways to do this. Here, I found them and pulled them together. Here, I'm going to search everything first. Okay, this one, I have an 11 to the c to the 5th, and it's positive. And that's the only one. Okay, now let's see, I have negative 4c to the 4th. Do I have any other? Oh, there we go. There's a second one. And then I have, gosh, I have a lot of different ones. Okay, now I have a 25c to the first power. Do I have any other c's to the first power? Yeah, I do, right here, a positive 15. And notice that we have just kind of a mix of everything. I do have a c squared, so a positive 3c squared, and I have a negative, oh, I need another color. Look at all the different terms we have. So we can't combine them all unless they have the same term, the same variable and the same exponent. So let's start pulling these together. I notice that my 11c to the 5th, I have no others. So I'm going to bring that one straight down. There is nothing to combine it with. So I'm done with that one. Okay. Oh, look at what I did. And this is why, notice that I missed one. That's okay. Since it's positive 6c to the 6th, I'm just going to put it over here. C to the 6th. And it's positive, so I need to come back and put my positive sign here. So see, even if you make a mistake, you can come back and fix it. Once you've colored them, it helps you see them as individuals. Okay, so I did my 6 first. I did my 5. Now I need my 4s. Look at, I have 2 4s of exponents of 4s. So I notice that I have a negative 4 c to the 4th and a negative 2 c to the 4th. Okay, so they're both negative. So that means I'm going to add them. I'm going to go negative 4, then negative 2, which gives me a negative 6c to the 4th. Okay, done with those two. Now I've gone 6, 5, 4. I'm going to look for the 3s. The 3s. Okay, I do have a c to the 3rd power, but I only have 1. So I'm just going to bring that one straight down, and notice that it's a negative. So I'm going to do negative 7c to the 3rd. That one's done. Now I've done 6, 5, 4, 3, 2s. I need my 2s. And my 2s, look at that. I only have 1 again. I only have 1. I don't have any other c to the 2nds. So I'm going to bring it all the way over here. It's a positive 3c to the 2nd. That one's done. Okay, now I've got 6, 5, 4, 3, 2. I need my 1. Now remember, there won't be a 1. We just know it's there if we need to. Okay, this one's a little trickier. Look at that. I've got a negative 25c, and I have a positive 15c. My signs are different, so I'm going to have to subtract them. I want you to think about a negative 25. We would go left, negative 25. And then a positive 15, I would have to come back 15. Now, when I come back 15, I'm still in the negatives. In fact, I'm going to be stuck with a negative 10c. Okay, so those are done. And do I have any constants? Do I have anything I haven't dealt with? I've got my c's. I'm looking. I have everything. There was no constant in this one. So yes, it is a little bit of work, but if you're organized, you will be able to get this done yourself. Okay, go ahead and work on it. I will be walking around.